Welcome to beautiful Ventana Room C and our first sessions of the conference. Hopefully you all are all well caffeinated. Um, Not sure about the next one. Mine's gonna be a little dry. Uh, I also have a lot more content that I'd planned on, so we're gonna go real fast. And anyone who's seen me before probably is familiar with that, because it tends to happen every time. So this is what I had promised on the agenda. Um, you'll hear a lot all over the place around data storytelling. And I think before you can tell a good story, you have to really understand your data. So we're going to talk about that instead. All right. So I'm also ending the conference with a presentation on data quality, where you're going to see junk in goes to junk out. This is something you've probably all seen before. What's in that arrow? There's a lot buried there. And sometimes we can actually use that arrow to fix some of the junk, right? That's data cleaning and pre-processing and stuff you're going to hear about with the next presentation. Um, and some of the data is just okay. It's not all junk, right? So let's talk about what we're working with. So you can do cleaning, you can do transformation, you can do analysis, you can do visualization. And ultimately, you might be telling a story. You might be creating some sort of a platform which users can leverage to find their own stories, right? If you're building a dashboard or something like that. But ultimately, the road to finding that story can be full of potholes and all kinds of fun stuff. Ultimately, if you don't have a solid foundation, you're not going to go anywhere fast. And if you do, it's probably not going to end well. So we're going to work on understanding source data. We're going to do that, talk about resources available, how to ask the right questions of the data, identifying patterns, drilling into those patterns, and we can talk a little bit about the story side maybe, just because. So first up, resources. All right, there is stuff out there, and there are several concerted efforts to make a lot more available to you at the enterprise level here at ASU. You might be familiar with the data dictionary platform that's available through the analytics portal. If you want to contribute to that, you can go to that metadata hero link and you can add definitions and whatnot for Redshift warehouse assets. You can go to our student data enrichment portal group to find all kinds of very detailed documentation on the stuff that we're building as part of those projects. And then there's some pin posts and where's that data with more information and links to all kinds of random data dictionaries and whatnot that have existed over the last couple decades. Depending on what system is being used to populate the data you're interested in, there might be some public documentation out there. If you're not familiar with the PeopleBooks documentation that Oracle puts out for PeopleSoft, there's a lot of fairly good information buried deep within those manuals. Use the search feature. Search for field names is my best suggestion there. You're not going to find everything. Some of the stuff we do is not what's stated in the documentation, but it'll generally get you 80% of the way there. And if you're using Canvas data, we recently moved to the new Canvas Data 2 platform. So you might have some old bookmarks laying around that are no longer relevant. If you dig hard enough, you can find their new stuff. You just have to click around on the website or go to that link. They also have entity relationship diagrams that show you how the tables are related to each other. And this is just the beginning. And obviously, there's lots of things that aren't covered here for people not working in this exact same spaces that I am. But that's what I'm aware of. Now, maybe there's not something that you can find out there or you don't know where it is. There's lots of ways to ask for resources. So we've got all these fun Slack channels. We've got different business units within the organization that have email addresses that are valuable sources of official information and generally responsive. So ask. Don't be afraid to ask. I've spent more time asking people about things than actually doing things. I guarantee you. All right. So that's asking people. Now we're going to ask the data. What are we going to ask the data? Well, we want to ask the data where it came from. And in order to understand where the data came from, you have to understand the business. So we think of roles like a data analyst as very technical in nature. But ultimately, you have to be tied into the functional side of things to truly understand what you're working with. So you want to know what the business processes are that are generating that data. You want to know what the business is doing, what changes are upcoming, what questions are being asked, what's being considered. And you want to make sure that what's staring at you in the data is put into the broader context. So you have to understand everything about not just the data you're looking at, but things that are related to it, right? We're going to start talking about covariates and all that fun stuff. And if you're getting requests from your stakeholders, your different units, you also want to consider beyond that request. So what are they asking? And then maybe what are they really asking? And then what could they be asking next week? And how could we get started down that road with this request right now? Get out ahead of things. So I like to say, is it something they want or is it something they need? And that's subjective, obviously, but it's up to the analyst to kind of make that distinction. So you want to follow up. You want to make sure you have a complete understanding of not just what they've said, but why they're saying it, right? There might be a better way to go about it. It might lead you into some other data that hasn't even been considered as part of the initial request. So make sure you truly understand what that request is and what else might affect it. And I know a lot of people kind of at the ground level fielding these requests can't say no, right? You're told this is what you're doing, so you're gonna do it. But always push back a little bit if you think there might be a better way, if you think it might not be worth it. I've pushed back on many marketing requests, for instance, because it doesn't have to be perfect. They can pull it off a dashboard, it's close enough. As long as it looks good, they're generally happy. So there might be a better way to do it as well. All right, so once you know what questions being asked and how you might want to go about finding the data, you have to think, okay, what's out there, what's relevant, what's not relevant, and then how is the data limited? So we don't have all the data. The university creates so much data that you're never going to be able to find in the warehouse and ODS, user databases, et cetera. So what's out there? And ultimately, we're looking at the data from a level of detail perspective, and that's some intersection of the grain, the depth, the detail, and then the attributes, which is the width, the breadth, the number of columns that you're seeing in the data. So every cell within that intersection of rows and columns is additional data, but depending on what your source is, it can vary dramatically in those two different dimensions. Timeliness. So is this data going to be relevant by the time we use it, right? So we're starting to see more talk of things like real-time data in ODS for lots of specific use cases. Those are probably going to start branching out a little bit. We're also starting to look at real-time data within the warehouse environment. And long gone are the days where we had census data and that's just what we used. And you couldn't answer any questions until October for fall students, right? Late October. What documentation's out there, going back to all those resources on the previous pages, get to know what that data is that going to be potentially helpful to you or not? And then if the data is not there, can you get it, right? Go find the data, connect with the warehouse team or data engineer of some sort, figure out how to get access to it, figure out how to work it into what you're doing. If you don't have the data, you can't use it, and it might lead to a blind spot when you're answering whatever question you're looking at. Okay, so looking at these data sources, again, going back to the documentation, what is this? Where's this data coming from? What's the source system? Who's putting it into the source system? How are they putting it into the source system, right? Is this a student self-entering information in a free-form text box and it's optional, right? Kind of worst case scenario right there. Or is it some system integration with a predefined field value list? Going to be much cleaner, much more useful, much more reliable. So understanding how it's being collected, why it's being collected, right? What is the purpose of this collection? That might help identify biases within the data potentially, might help provide relevance, accuracy, thresholds, things like that. And then once that data is collected, what's happening between the collection point and me pulling it out of whatever database I'm looking at, right? That's not necessarily the same data that was put in. things can happen along the way. It could be transformed. They could be imputing values. My favorite with null filling is if you're looking at like GPA in the warehouse, you're going to see a lot of zeros. That doesn't mean they filled every class. Just means they didn't have a GPA and we put a 0 in there because it's numerical field. So eventually you're going to figure out how to deal with all those, all that great stuff. The data could be aggregated or denormalized. So aggregation would be maybe the field you're looking at is a summary of something. There's a chance that the details that went into that summary, the individual unit level records, are available someplace else. So you'd be able to drill down into that. Denormalization, we start getting into like mixed grains, things like that. It can make the data a little bit more useful. You might want to go upstream. Okay, where did it come from to get here? It might be more usable in one of those closer to the source tables versus what you're specifically looking at. Had to find one of those in Slack recently. All right, so you want to know if the data is what you need. That's why we're asking all these questions. Okay, so it's going to be up to you to identify, is this data relevant to the question that's being asked? How reliable is it? All those things. Ultimately, what are the hurdles going to be to answer this question with this data? What are the downsides? And if you have future questions, it's also good to know who could answer those questions. So understand the data, how it's created, who knows more about it. All right, so now we're finding patterns in the data. We've got the data, we've got access to it. Yay, half the battle. Data profiling, if you're looking at something new, never a bad idea. Get familiar with it. So you got your basic numeric profiling, all your statistical metrics, text values, looking at all the different values that are in there. How common are they? How often do we have nulls in each of these columns? If there aren't any nulls, are there null equivalents? And if you're working with source warehouse data from PeopleSoft, yes, there are. Finding outliers. Are those outliers meaningful? The outliers themselves could tell you something about the data. It could tell you that the data is dirty, it's messy, it's not accurate, or it could tell you that there are some records that are just more meaningful because of something behind the scenes. And again, it's important to know how that data is being captured to understand why that outlier might be meaningful. So beyond individual columns, you might want to look at columns in relation to others. And so oftentimes, for instance, if you see a column of random codes, there might be another column in that table that has descriptions for those codes. Or there might be another column that's highly correlated with that can tell you more information about what those codes mean or where they came from or how you could use them. But you're going to go through all the columns. You're going to say, okay, here are the ones that look relevant. Here's the ones that don't look relevant. And here's the ones I have no idea about. Throw out the ones you know you don't need, right? If every record's null, it's probably not a useful column. And then once you have that subset, start looking for those patterns between columns. So things like frequency crosstab. How often does this combination of variables between these two columns occur? Right? You can learn a lot just by looking at that. If you're using a visual tool, Tableau, Excel, whatever, you have numeric data, you can always plot those to see if there's like a correlation there. You can do statistical metrics on those correlations, Pearson coefficients, all that fun stuff. How are these columns potentially related to each other? And what can I find out about that? Looking at things over time. So it might be, GPAs generally increasing over time, right? That's important to know for lots of different types of analyses. I did a project my undergrad at one point looking at the effect of the implementation of plus-minus grading. GPAs went up when plus-minus grading was introduced because there's more pluses than minuses. And so we were able to measure the impact of that. There might be text values, and all of a sudden, these new options show up, or some of these old options stop appearing. And so you're going to want to know, based on what time you're looking at, whether or not those are relevant, how relevant are they? If you're doing some sort of longitudinal analysis, how are you going to deal with these new values that have suddenly appeared and their effect on all the other values? And then I had this project at one point called pivot mining, which was basically looking at how all possible variable combinations related to each other and to some sort of a dependent variable. If anyone's interested in that, let me know. I'd love to bring it back up. I heard there's like companies doing this now. It's really messy, really hard to interpret, but it gives you all the potential insight with this type of approach. Okay, so that's kind of exploring the data just to explore the data, thinking about your use case a little bit more in detail now. It's okay, what am I going to be doing with this information? And how is that going to impact what I need to know about the source data? So if you're doing a dashboard with broad use cases, right? I'm putting this information out there because we know people need it. We don't know what questions they're going to be asking of it specifically. Well, in that case, we're probably going to need a lot more information. We're going to need a lot more data for those users in that dashboard. We might even need multiple levels of detail present. At some point, you have to figure out, okay, do we have enough variables? Are we now just adding clutter? So they're not going to be much return. There are not going to be many people using this variable. So why are we putting it on there if someone hasn't asked yet? So you have to consider all these when you're thinking of the scope of the data set that you're using. If you're building some sort of a statistical model, you're looking at things like significance. How much data is required given the variance within the data to get the level of significance that I need? Can we meet that? Can we not meet that? Do I need to find more data? We're talking about we're dealing with sparsity. Can I afford to throw out these records? Do I need to do imputation? All that fun stuff. If you've got categorical variables and you're doing something like one-hot encoding, you have to think about how is that process going to then affect all these patterns that I found, and again, sparsity, all that fun stuff. For the methodology you're using, same with PCA, you're losing information, you're losing detail. Is that information that is functionally required to answer the question? And depending on variable value frequency and things like that, PCA might be required, but it might be a problem. If you're doing any sort of data transformation, you have to think of the effects on the variance of the data, how it's going to affect things. Is it going to lead to more collinearity potentially? All these problematic outcomes. The source data accuracy and quality. So again, you might not be able to get through a PCA because you need that level of detail, that information. But is that source data sufficient to answer the question to begin with? Is it reliable? If you're answering a very specific question, and that's a very important value, then obviously your quality requirements, your accuracy requirements are much higher versus if it's just some random covariate that you're throwing in just to help deal with some of the noise. All right. Small n's, so small frequencies. If you're thinking about creating any sort of bucketing value or composite value, doing some sort of an aggregation, again, that can all affect those frequencies and level of detail and all that fun stuff. Okay, validating what you've done. So if you've got things that you still haven't been able to figure out, looking for patterns, asking questions, I will say, if you're dealing with student data, it really helps if you've been a student at ASU. One, you're going to understand the processes that students go through, but also you're going to have some sample data that you're intimately familiar with. So I have a lot of records at ASU. I have 4 siblings who have all been to ASU. I can check pretty much any use case, and I'm one text away from getting clarification on what happened there. So find some good use cases. Find some coworkers who might be in your data sets. It can be incredibly invaluable. Once you found these patterns, you can validate them. So do they seem reasonable? You might have a general understanding of the process. Does the data match what you would expect to see given your understanding of the process? Or you might have heard something about some pattern, high level, within ASU's marketing materials or something. Is that what I'm seeing within the data, or am I off base, or potentially are they off base? Is there some secondary data set that might be able to support what you're seeing? Is there a secondary source of information? Is there something that you would expect to correlate that you could verify patterns with? Um, if you're familiar with survey design, or if you've ever taken super long surveys, it might be like, why are they asking me the same question over and over and over? Well, they ask you in slightly different ways to see if you respond exactly the same way each time. That tells you them if you understood the question. Well, we can do something similar with the data. There might be related data points that we can compare to verify that we have an understanding of the one that we're specifically interested in. And of course, if someone's done it before, compare it, right? There might be materials out there. If you're doing any sort of research, obviously you're going to be familiar with like literature reviews. We can do something similar in our space, right? There's a lot of people, I guarantee you, we're repeating work over and over and over across the university. Someone out there's probably done something similar that you can build from. So check out documentation, ask questions. All right, so we've got patterns, we've verified our patterns, pretty good feel for our source data, ready to go forward. Let's start figuring out what our story might be. Again, what are those? You have all these variables that might be relevant. What's most relevant? What's most directly relevant? What's most explainable to the problem at hand? How reliable is it? Is it even worth it? The reliability might not meet that threshold that you've set. We have a lot of very bad data, and it's just an unfortunate reality that we have to deal with. So sometimes you can't answer the questions. If you have a dependent variable of some sort, obviously which variables correlate with that most strongly. If you do have a correlation, obviously that doesn't mean causation. So what theoretical reasoning can you come up with that could potentially define it as a causal relationship? How can you explore that further? Is there some sort of natural experiment within the data that you could evaluate? Looking at outliers again, high variance, low variance, both can tell you different things about the records, about the data generally. So thinking through like, what does all that mean in the bigger picture before you actually start creating a final product? All right, so dissecting patterns, bringing in additional information for context. So another data set that you might be familiar with, might have descriptive data for something that you're looking at. But ultimately, you've got, when you're working with patterns, you generally start out with two variables. You probably have some sort of a covariate and some sort of a dependent variable. So this is bringing in a third in different ways. So if you've got something cross-sectional, so you're looking at differentiation within a population, okay, how is that changing over time? Let's bring in the time variable. Or if you're looking at something changing over time, is that consistent across all the different populations? There might be another story within that that's worth surfacing. And sometimes you might find something like an occurrence of Simpson's paradox. If you go to Wikipedia and look up Simpson's paradox, you'll have an example from like Berkeley admission rates or something. Very informative, definitely something to keep in mind. It's about how the story can change when you consider just one additional covariate. Again, my pivot mining thing, and obviously something like multivariate regression is going to tell you a much better story about the data than anything univariate. All right, bounding your story. So your story is a summary of the data's stories. So you found a story within your data. How are you going to translate that, interpret that, summarize that for your intended audience? Again, it goes back to that business question that you're starting with. You're going to think of your audience. What's the appropriate level of detail? Big on transparency. So if it's not in your data, you don't know it. You can speculate, you can assume. If you're making assumptions, if you've done some sort of inferential imputation within the data, like make sure it's clear that you've done that. If there's anything you found within the data regarding accuracy, reliability, things like that, make sure it's clear to the end user that that's potentially a problem. You know, you can only do so much. Footnotes, citations, all that kind of documentation. Generally try to keep it close by whatever you're presenting. I've found that if you put it on another slide, that slide will quickly disappear as soon as it goes up the ladder. So put it on the same page. But if you have to, appendixes, at least you're covering your own butt, right? Make sure it's out there. Make sure they know it's what you did. And yeah, the rest of it's just storytelling. We're not doing that right now. All right. Right on time. Quick questions. Haley. So I generally do a little bit of SQL initially for basic frequency distributions, things like that. Then I'll quickly put it into Alteryx just because it's faster to do a lot, I've found. Like even if I'm just verifying the grain of the data, I think it's generally faster to do it in Alteryx. Um, and Tableau's more of a last resort, or when I start getting into like longitudinal patterns, things like that. So generally speaking, if you're working within our enterprise environment, um, if the size of the data seems to be problematic, you might be able to tweak the SQL a little bit because we have immense processing resources within the warehouse, things like that. But if you can't get around it, obviously sampling, right? I've had a lot of times within Alteryx, for instance, where hit the memory limits real quick. So looking at, instead of looking at all the columns at once, subset them. These 10 columns, these 10 columns, these 10 columns. Start finding those relationships and then filtering it down that way. But yeah, I mean, you got to limit the data. If you're having processing problems, you either need more resources, more efficient process, or you have to limit the data. All right. Other than my GPA increasing because of plus minus grading. um, Back in my Ed Plus days, we did a lot of retention analysis. And so we'd look at retention not just the way the university tends to or has tended to up until recent years at least. We dissect it with a ton of different dependent variations. And we'd find some really interesting patterns depending on which variation we used. And so we found that we could make retention look really good with AH online students, or we could make it look really bad with online students, depending on which metric. We could show it going up or we could show it going down. And so kind of looking at these different perspectives and then introducing covariates allowed us to find out a little bit more about why that might be occurring. And that was a signal that there was something more fundamental we were missing in the data. That's the tip of the iceberg. There's 10 different types of session to session, 3 different types of year to year. Yeah, 30 types of year to year. All right. Thank you.